let's get started with EchoView and the code operator. So we start with EchoView variables, which represent time series measurements, example, the SVTS, etc., from an echo sounder. EchoView then uses these variables to store, manipulate, and then display that data. This way, the raw data from the echo sounder remains unchanged. So note that the term variables in computer science refers to a storage location associated with a symbolic name. So take note of the context that when we use the term variables during this webinar, and also when we're referring to the code operator in general. An overview of the code operator is that it is an EchoView virtual variable. It is a Python API that is devised to transform echograms according to a filter algorithm of your design. So that's what makes it so powerful, the fact that you can create and program your own algorithm or filter. It accepts other EchoView variables as input, performs computations on the associated ping samples in Python, and then returns the output to EchoView. And the ping samples are the SVTS or power values of the data, typically. Okay, and it comes licensed with the advanced operators module. The objective of our webinar today is to impart the concepts of the Python programming language for you to write code operator programs or to modify existing ones. And we'll proceed by dissecting the code in the default EchoView Python source file. As always, you can refer to our EchoView help file as a resource for the code operator. And the main page is the using the code operator page. It's got many of the details that I'll be covering in this webinar. And you can also contact us at support@echoview.com. So before we actually go into the code operator itself, here's a brief look at what it can do. So if you look at the plot at the bottom right, that's a collection. Well, it shows you the frequency response, or it shows you the combination of frequencies that were above a different threshold from 5 of these echograms. And using a custom color legend in EchoView, it shows you it can be used for a species identification based on the idea that different species have got different backscatter properties at different frequencies. So I will show you what the code to code that in EchoView in the code operator looks like. But basically, in the data flow window used for this kind of analysis, you can replace all of these variables with a single code operator variable. Okay, and I'll show you in one of my examples towards the end of the webinar how we do that. But for now, let's get into the code operator itself. So when you create a code operator in EchoView, you see it appearing in the data flow window. And if you go into the variable properties dialog box, and on the operands page, you can choose the operands from the drop-down menu from this option over here. And then you can add new operands or remove the previous one. Then if you go to the code page, you can specify the Python source file, which contains your code, your Python code, or you can click new to generate the default EchoView Python source file. And we'll look and we'll see what that is in a couple of slides time. You can also specify the window size pings parameter, which is an odd numbered integer in this text field. Now I'm showing you all these settings now because we will encounter them in code later on. Okay, so that's just to introduce you to where they are. So when you click new to generate the default EchoView Python source file, this is what you will see. Now the colors here you can customize based on the text editor that you're using to code in Python, right? But if you remove all the comments in the default EchoView Python source file, it condenses down to something like this, 7 lines of code. And so for the duration of this webinar, I will be using this as the default EchoView Python source file. And here's an overview of what it does. Okay, it starts by using import to access the typing, EchoView, and NumPy packages. All of these come pre-installed with EchoView. Then it defines the operator class and the eval method within that class. Okay. Eval then copies the input from operand 1, so this is operand 1, to the variable first input. And then the return statement communicates the ping samples from eval to EchoView. and the value of the ping samples do not change. So the default EchoView Python source file basically just makes a copy of the data from operand 1 and sends it back to EchoView. Right? Before we go any further, take note that when you write your own Python source files, the number of ping samples that you return to EchoView must be the same as the input. So the code operator is developed according to a paradigm in computer science known as object-oriented programming. And so we'll introduce several ideas here in OOP that you need to know or have an inkling of in order to use the code operator, right? And let's start with trying to understand what an object is. In Python, when you create a code operator in EchoView, you observe it appearing in the data flow window. Now, in Python, this is known as an instance of the operator class, or simply an operator object. And so what you define over here, a class operator, okay, in code corresponds to what you see over here in EchoView. So it's necessary to declare the operator class in any Python source file for your code operators in EchoView, okay? You can think of these two things as being analogous. Okay, this is what you see in EchoView, and this is what you code up in Python. Then you can program the behavior of this code operator object with the code in the operator class. Objects have got two features called attributes and methods. And attributes are variables and methods are functions. And these characterize the state of the object and its behavior respectively. And we'll define both within the class body of the operator class. Okay, let's start with methods. A method is any Python function defined inside a class body. So we start off with in Python, functions have got this keyword def. Okay, and the code following the def keyword up to the colon at the very end inform you of the name of the method and its parameters, which are in brackets over here. So the name is eval, and then the parameters are separated by commas. So in this case, we've got two parameters, self and inputs. Okay, let's dissect the eval method. So what does eval do? Eval performs computations on the input pings, and then it conveys the results back to EchoView. Now you need to declare it in your Python source file. It has got two parameters. First is self. Self, this parameter governs which object the method acts on, and I will elaborate on this in a couple of slides. And then we have got the inputs parameter. Now, this is a list, a Python list of all the operands that you specified in the variable properties dialog box in EchoView. Okay, because it's a Python list, we can access operand 1 by using zero indexing. So input 0 corresponds to operand 1. And then if you were to add subsequent operands, input n-1 corresponds to operand n. Now you notice that up here in the definition, when you see it of the function in the default EchoView Python source file, you have inputs, colon, and then you've got all of this text over here, a list, open bracket, ev.operand input. Now this is a feature in Python known as function annotation, and it seeks to inform you of the kind of object that parameter needs to be. Okay, if we didn't have that, we wouldn't know what inputs is. It could be a string, an integer, a float, a list, anything. But now we know that it's a Python list of operand input objects from the EchoView package. And I will explain what all of that is later on during the webinar. Okay. The main thing to note is that you can, in your code operator, in your Python source file, you can just refer to this parameter as inputs. You don't need to refer to anything after the colon over here. So I told you, I'd tell you what self was. So in EchoView, you've got your code operator object, and then correspondingly in Python, this is the Python source file. So this is what this looks like in code. When EchoView invokes the eval method, so EchoView will call eval, all right? Self is the parameter that Python uses to pass this particular object into this method. So it's something to do with the way Python works. Well, in particular, the way OOP in Python works. It passes this object into this method via the self parameter. So that's the role of self. not only in this method, but for attributes as well. So like methods, you define attributes within the class, and attributes allow you to assign traits to the object of the class in the form of variables in code, and they can be a dictionary, a float, integer list, or even other objects. Okay. So we'll now dissect this statement at the end of our default EchoView Python source file because it contains a couple of attributes. All right. First input over here, right, is the variable name assigned to input 0. Okay. And we will see shortly that this is an object of the operand input class. Okay. But function annotation has already given us a hint that this is an object of the operand input class. Right. Now, objects of the operand input class have got an attribute called measurement. So first input dot measurement accesses the attribute, the measurement attribute of the operand input object over here. Now, this in turn is an object of the measurement class. So first input dot measurement is an object of the measurement class, which has got an attribute called data, right? Which accesses the ping's input samples that you return to EchoView using the return statement. Now, note that on this slide over here, measurement with a capital M and measurement with a small m are different things. Okay, this is the name of a class, right? This measurement small m, okay, that you see over here is simultaneously an attribute of objects of the operand input class, and it's an object of the measurement class. I've introduced two new classes over here, the operand input class and the measurement class. These are classes in the EchoView Python package. Yeah, and the EchoView Python package forms the backbone of the code operator. You make use of the code or the tools that are in the EchoView Python package to write your code operator programs. You need to import it into your Python source file. Okay, and in the default EchoView Python source file, it is done through using the statement into import EchoView as EV. And this syntax allows you to access this package simply by calling EV instead of typing out EchoView in its entirety. Okay. Now, what this package does is that it gives the operator class access to the following classes: operator base, operand input, measurement, and measurement type. And now for this part of the webinar, I will go through each of these classes with you, including their methods and attributes, because you need a notion of what these classes are and how they work in order to harness the code operator. Starting with the operator base class. Now, technically, this is again in object-oriented OOP speak. Okay, it is the parent of the operator class. Okay, but for our purposes, you can think of operator base and operator, the operator class in the default EchoView Python source file as being analogous. All right, and you need to derive operator from operator base by using the syntax. So class operator open bracket ev dot operator base close bracket. So what this does, it gives the operator class that you are coding in access to the attributes and methods in operator base. Okay. So what are the attributes of, well, both these classes, operator and operator base? We have window size, and this is the integer that you input on the variable properties dialog box. So whatever integer you put in here, you can access in your Python source file via this attribute. And as for methods, there are two: eval, which we've already discussed, and result type. So result type, the reason why we need it is because the code operator's output defaults to the data type, whatever the data type is, SV, Angular, TS, Boolean, of operand 1. Okay, and you can use this method to modify the output, for example, to that of a completely different operand or to another data type that's supported by EchoView and the code operator. So let's see how we can use the result type method. In this screen grab on the left, this is the default EchoView Python source file. And then on the right, up to this point, it's exactly the same as the default file. All right. And then I've defined the EchoView, the result type method over here. Okay. Again, it takes two parameters, self and input types. Input types is again a Python list. And this time, instead of operand input objects, it's a measurement type objects. Now, measurement type is a class in the EchoView package, which we haven't seen yet, but we will see later on. But now you know what type of object this parameter needs. Okay, so it's basically a list of data types. And in this case, data types corresponding to all the operands that you've specified in the variable properties dialog box. And in this case, we're returning the data type of operand 1. So having said all of that, the function of this code behaves exactly the same as this code because by default, EchoView returns the data type of operand 1. Moving on to our next class, which is the operand input class. Now, this is a window of measurements. I've got measurements here in a different font because measurements here refers to objects of the measurement class. Okay, but now what does this mean? What does window of measurements mean? Okay, let's take a step back, starting with EchoView. And for example, if you've got an echogram over here made up of individual pings that you specified as operand 1 into the code operator, and you set a window size of 5. Okay, and this is a schematic of what Python is doing. Okay, it says here it's a window of measurements. This list over here, okay, is the window, and each of the objects in it is an object of the measurement class. So the operand input window is this list that corresponds to the length of window size pings, which is why you've got 5 objects in here right now, according to this example, of a measurement class object. So also note that the code operator, okay, iterates through the pings of your echogram non-sequentially. Now this is for optimization reasons, but basically you can process ping 10, then ping 12, back to ping 5, then ping 3, okay? Then the ping that is currently being processed, okay, is known as the matched ping, okay? So the current input ping into the operator is known as the matched ping and corresponds to the output ping, okay? And the point of the window is to give you access to pings that are adjacent to the matched ping. So you can make the window size pings as large as you like, and that gives you access to more pings adjacent to the matched ping. Now we've got enough background to look at the attributes of this class, of which there are 3, starting with window measurements. So this is a list of measurements, so this entire list. Then window index corresponds to the integer index of the matched ping. So in this case, because of 0 indexing in Python, window indexes 0, 1, 2. And finally, measurement, which is the matched ping. All these 3 attributes are related by the following statement, okay? Window measurements, which is a Python list. And if you give it the index of the matched ping, you get the matched ping. So that's all for the operand input class because it's got known methods. And then we move on to the measurement class, which corresponds to each of these objects. Each of these items in the list are objects of the measurement class. So each object represents a ping, and it's got all these attributes, which are the various kinds of properties of a ping that you can access with the code operator. Now I've highlighted data here because that is typically the attribute that you use to, well, that you're going to be using in your code operator because that corresponds to the data values of the ping. Okay, things like beam angle and beam width are only available to multi-beam data, and then a data complex is only available to wideband data. This class has got one method called cal, which takes one parameter, which is a string, and the value of it returns the value if you call cal. If you call the cal method, it returns the EchoView calibration setting given by the name parameter. And if you refer to the about calibration settings page in the help file, you can see a complete exhaustive list of the calibration settings that you can access with this method, okay? And here's a brief look at how you use that method. In this example, I've just got the eval method, okay? And if you look down here, input 0 corresponds to operand 1. And we know now that it's an object of the operand input class, which has got a measurement attribute, okay? So simultaneously, operand.input measurement, this is an object of the measurement class, which is this class. And we've assign that to the variable refPing. So now we can use the methods of the measurement class on this refPing object. And so we use the cal method to find out what the pulse duration is. And we can similarly use it to find out what the two-way beam angle is, and also determine the sound speed setting that's used. Okay. Finally, we have the measurement type class. So Ecoview organizes the ping data based on their types, whether it's Boolean, Angular, SVTs, or others. And this mechanism is implemented in the code operator via this class, this measurement type class. It's got all these attributes, which basically is basically a list of all the data types that are currently supported by Ecoview and the code operator. And if you want to find out what each of these is in detail, go to the using the code operator help file page. We've got the description of what each of these is. It's got several methods, all of which return a Boolean, and they're basically useful to test what kind of data type is being processed by the code operator currently, whether it's acoustic, single beam, multi-beam, if it's in decibels, linear units, or it's wideband or pulse compressed. Okay. So let's briefly look at how we can use the attributes and the methods of this class in our Python source file. So again, up to this point, we have got the default Ecoview Python source file, and I've now defined result type. And instead of just returning the data type of operand 1, we're going to use the conditional statement to test, okay? Since each of the methods over here returns a Boolean, we can test, okay? If the data type input 0 is the corresponds to the data type of operand 1. So if the data type of operand 1 is acoustic, then we return that data type, okay? Return the data type of operand 1. Otherwise, in this else statement, we say we return the undefined data type, which is an attribute of the measurement type class, this class basically, which is found in the Ecoview Python package. Okay, so that's basically it, okay, the essentials of the Ecoview Python package. And before we go into the examples, I'll give you an overview of what we've covered. We've talked about the operator base class, which is the parent class of the operator class, which is required in your Ecoview Python source file and communicates the ping data to and from Ecoview. Then we have the operand input class, which is the list of which is a window of measurements as a Python list. And the size of this window is set using the window size pings parameter in the variable properties dialog box. Next, we have the measurement class, and each ping of the operand input window is an object of this class. Okay. And finally, we have measurement type class, which is used for data type management. So just before we dive into our examples, note that the ping samples in the measurement.data attribute are a collection of values in a NumPy array. Now, NumPy arrays are a popular data structure format in Python, okay? And we'll use the term shape to refer to the dimensionality of such arrays. What do you mean? So if you're talking about single beam echo sounder data, all right, this would be a 1D array of ping samples as a function of range. So one ping, a ping, the samples in there are a function of range. And so we say it has got shape, range in brackets, okay? Now, in contrast, for multi-beam data, okay, measurement.data is going to be a 2D array of shape, range, comma, beam, okay? So if it comprises of 200 range samples and 50 beam samples, we can also say that it's got shape 250. And this is useful for you to keep track of the kind of data that, or what the data, or the kind of data that you've assigned to variables in your Python code. Okay, and I'll stress again that the shape of the output needs to be identical to the input when you're returning it to Ecoview with eval. We will also see this init method in the example Python source files coming up. And this is an optional method in the operator class, and it's called automatically whenever a code object is instantiated. And instantiated means when you create a code operator object in Ecoview, okay? And use it to define custom attributes of your operator object. And note that it only takes one parameter, self. So this, we briefly saw the echograms, this analysis early on during our webinar, okay? And it's based on and replicates the classification system used in the Jack and Michaels 2006 paper for species identification, right? And into your code operator, the operands correspond to SV echograms at different frequencies. So all of them have got different frequencies down here, and let's say we just give it 5, okay? Now the algorithm assigns a unique integer to every SV echogram, okay? So if you look over here, we've got 3 different pings from operands 1, 2, and 3. So each of these pings over here is at a different frequency, okay? And we assign them an integer at the bottom over here. So we called operand 1, 1, operand 2, 3, and operand 3, 7. The term that we use to, or the name that we give to these integers is the category codes. And they've got the unique property that any mix of them records a distinct sum. So that way you can look at the sum and then you can work backwards and find out which collection of frequencies contributed to that sum. So when do we sum these numbers? We sum them if the SV value at the range exceeds a threshold. So let's look at this particular range point. Over here, the SV value at this point, the SV value at this frequency, and this frequency exceeds our given threshold. So we add 1, 3, and 7 to get 11. However, further down at this range, the SV values at operands 2 and 3 exceed the threshold, but not 1. So we add 3 and 7 to get 10. Okay, so that's the idea. Let's implement it in code. So this is what that code looks like. We start off as usual by importing the EchoView package. We access NumPy. We'll use some of its methods later on. Then define the operator class by deriving it from operator base. Now we've got init. And in init, we program the threshold and category code attributes. And we set our threshold to -66 dB. And these are the category codes or the integers that we're going to assign to each of our echograms at different frequencies. Okay. Now let's skate over result type for a minute and jump straight to eval. I'll come back to that later. We assign the input, we assign operand 1 to the variable first input. Okay, and we call NumPy's zero-like method, okay, and passing the parameter first input measurement. First input is an object of the operand input class. It's got a measurement attribute. First input measurement is an object of the measurement class, and it has got a data attribute which resembles the pings. Okay, what NumPy's zero-like method does, it creates an array of zeros exactly the same shape as this array. So what we have here is an array of zeros that represents the range of the ping. Okay, a 1D array of zeros that represents the range of the ping. And then we assign that to our variable summed category codes. So this array of zeros is where we're going to accumulate our category codes next. And that's what the for loop is for. And the for loop declaration corresponds or consists of these elements. Okay, starting with zip, we use this is an inbuilt function in Python. And what zip does when we've given it inputs, so this is our entire list of operands from the variable properties dialog box and the category codes, and zip couples them together. So this is how we assigned every frequency to an integer. Then at the start of each iteration, our for loop reassigns the variables frequency and category codes. Okay? It reassigns them to subsequent pairings of inputs and self.category codes. And this is how we assign every frequency to an integer in the for loop. Okay. Finally, we use NumPy's where method. And NumPy's where method is a useful method because it replicates a combination of a for loop and an if statement. Okay. It takes 3 parameters. So we count the parameters over here: 1, 2, 3. Okay. The first parameter defines the if-else condition. Okay, so we're going to test, okay, where in our input ping does the data exceed our specified threshold over here. Okay, and then if it does exceed the threshold, then this second statement over here, okay, some category codes plus category codes is executed, and that's how we add the category codes. Okay, if the condition is not satisfied, okay, then some category codes stays the same, and this parameter preserves the current value in our category code array. Okay, then after we've looped through all our frequency and category code pairs, we exit the for loop and return our sum category codes array to EchoView. Okay, so this is why we need result type, because the code operator returns the data type of operand 1 to EchoView. And in this case, the data type of operand 1 was an SV variable, but we are now returning a variable of a list, a Python array of integers that is not in DB units. So then we use result type to change the data type to single beam linear instead. For our next example, we'll look at creating a circular mask for multi-beam data. And this is significant because currently in EchoView, we can't create regions to flag bad data, for example, in multi-beam data. Okay, and we're going to create a circular mask and then set all the ping samples in there to no data regions. So the algorithm, basically the algorithm that we're going to implement is that for a given circle, all right, with center at some range from the transducer and some offset angle from the center of the beam fan and some radius capital R, okay? So R0 is the range from the transducer and phi is the angle offset from the center of this fan of the mask. And given a mask of radius R, we're going to set all ping samples to no data, okay? And I've got here ping samples, a function of range of angle R theta. So we've got R phi over here, which is the center coordinate of our circle. And then we've got R theta, R0 phi, excuse me, for our mask. And R theta over here. Now this corresponds to each and every single coordinate in this ping. Coordinate of the ping sample. So every ping sample has got its own individual R and theta coordinate. Okay, so expressed mathematically, we're going to say that we're going to set R theta to no data if the distance between the circle, or if R0 minus R is less than the radius of the circle. So we're going to test all the points around, in the ping, and if it falls within the circle, we are going to set it to no data. Right, how do we implement that? Okay, go through the usual process, importing, in this case, we've imported the typing library as well to use function annotation and the EchoView package and the NumPy library. Then we've got the operator class and in init. Okay, we're going to set up the parameters for the circular mask. Okay, its range, we're going to set it at 6 meters. This corresponds to R0. The angle, we're going to set it to -6 degrees, phi. And then our mask is going to have the radius of 0.5 meters. Okay, so R0, R, and phi are defined here in this example of multi-beam data for you to see. And each of these color square things corresponds to ping sample data. Note that for measurement, for multi-beam data, measurement.data has shape range beam. So we want to get in order to get the sample count over here, all right, which is this variable, okay, we call ping, which is an object of the measurement class, which means it's got a data attribute, and we find what the number of the number of ping samples has in the range domain by calling shape attribute on this NumPy array, and 0 gives us the range, and 1 will give us the beam. But right now we're just interested in the range. Okay. So why do we want sample count? Okay. We want sample count because we want to get the sample thickness variable over here. Okay. And we do that by subtracting stop range, subtracting start range from stop range and dividing by sample count. Start range and stop range are attributes of the measurement class object. So ping, the ping variable over here, which is a measurement object, has got stop range and start range attributes. And we divide by sample count to get the sample thickness. And then we divide that by 2 to find the midpoint of that. Okay, so that's, we call that the half thickness. Okay, then we use NumPy's linspace method to find the essentially the R values of all of the samples in this beam, okay, by giving it the parameters of the first step and the final step, and then NumPy's linspace method will automatically generate all the other values in between, okay, equidistantly. Okay. Next, we want to find the angles, okay, and we do that by using the beam angle attribute. So beam angle is an attribute of the measurement class objects, and by default it gives you the angles in degrees, and we use NumPy's radians method to convert it to radians. Because later on the computations that we're doing, we'll need to have these in radians. Okay. Use NumPy's mesh grid method, okay, to automatically populate or derive all of the ping sample coordinates. So that's a very useful method. Okay. In one line of code, we get all the R theta values, which we then assign to the variable sample range and sample angles. Okay, in this section of code over here is where we compute the distance between each ping sample and the center of our circle. So all of this basically is going to test each ping sample relative to the distance of the center of the circle. And then if that is less than R, again, we use a NumPy's where method. And our condition is that, okay, if the distance of the ping samples to the center of the mask is less than the radius of the mask, we set it to no data. Now, no data in Python, in EchoView corresponds to numpy.nan in Python. Nan stands for not a number. So .nan in numpy.nan in Python corresponds to no data values in EchoView. Okay. Now, if this condition is not satisfied, then we simply return the ping data. Okay, and we return that to EchoView. And this is what we get. Okay, so in summary, okay, the code operator is an EchoView virtual variable. It comes licensed with the advanced operators module. Okay, it's a Python API that allows you to devise filters or algorithms of your own design, and it's based on the EchoView Python package, which comes installed with EchoView, that contains these 4 classes that you can use to program your code operator to make it do what you want it to do. Okay, and you can find all the information that you need on the using the code operator page in the help file, or you can also contact support@echoview.com. Finally, we've got a code operator tutorial in our pipelines, and it contains all the information covered in this webinar and more, and also has exercises to help you gain some experience in using the EchoView package. Okay, so that's it for this presentation from me. And if you've got any questions, please fire away. You can use the chat window.